Imagine if we could zoom in on an atom in your body, we would see a nucleus of protons and neutrons, surrounded by electrons swarming in orbits. So we would think, okay, these are the fundamental particles of the universe, right? But what if I told you that you are wrong, and that there are particles which constitute these? If we could zoom in further to one of those protons or neutrons, we would find something even more remarkable, point-like particles with almost no size at all, which make up these subatomic particles. These particles are the quarks. Quarks come in 6 different flavors. They are not your regular flavors related to taste, but rather are the properties of the quarks themselves. So there are 6 flavors, or rather properties, and they are called up, down, charm, strange, top, and bottom. These flavors are kind of like different types of Lego pieces that can be put together to make different structures, like a house or a car. The different types of quarks combine in different ways to make up all the different types of particles in the universe. Now quarks are classified as fermions and are like tiny spinning tops. When scientists study how they spin, they found that they spin in a way that's different from bigger objects, like a ball spinning on a table. Scientists have a name for the way quarks spin, it's called half-integer spin. This means that the quarks can only spin in certain ways, and they can't spin in the same way as other particles that are bigger than them. This is what makes quarks special and different from other particles. Now, because of having half-integer spins, quarks are subject to Pauli exclusion principle, which states that no 2 fermions can occupy the same quantum state at the same time. It means that no 2 of these particles can be in exactly the same place and have the exact same properties at the exact same time. This property gives rise to the structure of matter as we know it, with atoms and molecules forming due to the interactions between quarks and other subatomic particles. Quarks are always bound together by the strong nuclear force, which allows them to form composite particles called hadrons. Particles made of 2 quarks are called mesons, and particles made of 3 quarks are called baryons, which include protons, 2 up and 1 down quark, and neutrons, 1 up and 2 down quarks. There are particles called tetraquarks that are made of 4 quarks, and pentaquarks that have 5 quarks, and some of them are almost stable but do eventually decay. Now, let's delve a bit deeper into the 6 different flavors of quarks. Up and down quarks are the lightest and most common flavors, making up the protons and neutrons in the nucleus of an atom. Charm and strange quarks are heavier, and are found in a variety of other particles such as mesons and baryons. Top and bottom quarks are the heaviest, and are only produced in high-energy particle collisions. In fact, the top quark is so heavy that it decays within a fraction of a second after being produced. In terms of size, quarks are incredibly small. They have a diameter of less than 10 to the power minus 18 meters, making them virtually impossible to see or detect directly. Instead, physicists use particle accelerators to study the properties of quarks and their interactions with other subatomic particles. Well, quarks are one of the most fascinating and important particles in the universe. Their properties and interactions with other subatomic particles have a profound impact on the structure of matter as we know it. As our understanding of quarks continues to deepen, we can expect to make even more exciting discoveries in the field of particle physics. So that was it on this video. Thank you for watching, and I hope you found this explanation of quarks to be informative and interesting. If you have any questions or comments, please feel free to leave them below and don't forget to subscribe to my channel.